Okay, in this lab I want to talk about footprinting and reconnaissance utilities. Let's talk about the ping command. So what I'm going to do is open up a command line terminal here and just really maximize this to get the best use of our space. The basic functionality of this tool is to really just test connectivity between the source and the destination. There's a variety of different ways in which the protocol can be used. You can, depending on what utility or where you're actually doing it from, meaning a host or a router or a switch, etc., or Unix box, really depends on the protocol used, and you could use a packet sniffer to realistically look at exactly how this happens. But we're going to take a look here briefly on a Windows client. For the most part, it's all basically the same. You do get some results that are different, like I said, depending on what the source is. But from a Windows client, we're simply going to go to the command prompt and we're going to type in ping space / question mark, and we're going to see what types of options we have on Windows. So as we review this, you can see that there's a TAC T. This basically just forces ping to operate and keep pinging and pinging and pinging and pinging and pinging until you tell it to stop. There's -A or TAC A for resolving the actual IP address to a host name. There's TAC N if you only want a particular number of responses to come back. You can set the buffer size or the size of the packet going across from the source and the destination using a -L. You can do an F for fragment. You can do a TAC R for record the route, but that only works for IP version 4 only. You have a TAC W, which is for the timeout value actually in milliseconds. You also can specify whether you want to use IP version 4 or, more importantly, version 6, since that is likely to be on the upcoming horizon. So don't forget you can set ping to operate in IPv6 mode by just adding a -6 to it. So let's go ahead and clear our screen and then just take a few examples of what this looks like. So I'm going to type in ping www.leodrager.com, and you can see that I'm going to get basically 4 responses back, and you can see that leodrager.com is being hosted at the IP address 199.195.119.130. I can also do this kind of in reverse if I want to. I could do a ping -A 199.195.119.130 and hit enter, and it'll try to resolve this in the reverse way, and if it can come up with a name, it will. In this case, the only thing that we're able to find here is that it's actually being hosted at server 10 at supercp.com. So that's helpful in some of the things that I would look for. Also, you can see that the size right here is routinely 32. If I look down that column here, you can see that the timeout values are constantly in the milliseconds, and they average right around 40, which, you know, is pretty, I would say, normal. And then also the time to live, which is the number of hops along the route until it'll time out. In this case, 56, which is more than enough to get to this destination. We also get a summary sent here, and it says, you know, it sent 4 packets, it's received 4 packets, and at 0% loss. Other values here would be 100% loss. Every now and then you'll get something that's dropped, you know, maybe it'll drop 1 out of the 4, and it'll come up with, you know, something like, you know, 25% loss or 50% or 75. And that again is using it depending on the number of actual ICMP types and codes that actually sent across. So that's the basic construct of the ping command. Now we can also do this a couple different ways and actually see, you know, this command used differently, and this is what I would go more into the intermediate or advanced style labs. So what we can do is we can ping www.leodrager.com. In this case, we're going to add an F and then the load size of 1500, And you'll see here what comes back. It says packets need to be fragmented, but the defragmented bit is set. So sometimes we can use that to our advantage and just learn a little bit about what goes on between our source and our destination. Now, in this case, there's likely to be a firewall between the source and destination, and that's pretty indicative of basically not allowing the fragment bit to set. But what we could do here is we could change this. I could change this to like 1200 for the load size, and you can see that I actually get responses when I set my load size to 1200, but I don't get them when the load size is at 1500. And again, I'm telling fragment both of these packets. So at 1500, the packet needs to be fragmented, but at 1200, it didn't. So what I realistically could do is I could kind of just start guessing at this point and see exactly where it starts timing out and where it stops timing out. So I'm just kind of incrementing up here. It went from 1200 to 1300 to 1400, and then I'll go to 1499, and you can see 1499 is too high, but 1400 was too low. So we'll just we could keep doing this until we got right at that happy medium. So there's 1450, it worked. We could jump up here to 1475, and we realistically could dial this in. So it's going to be somewhere between 450 and 475. So let's try 1460. So it's above 1460. So let's do 1466. 68. 69, and we're going to keep doing this until we get to that point where we know exactly where it is. 70, 71, 72, 73, and there you go. So right between 1472, which I got a reply, versus 1473, in which I did not get a reply. That's basically the magic number and what I would be looking for. And so that's some pretty good information right there in terms of learning about between what goes on in the source and the destination, in trying to find out exactly how things are configured. Because remember, there's going to be a lot of variables in between wherever you currently are versus wherever your destination currently is. So I'm going to go ahead and clear the screen, and we're going to do a couple other things here. Let's try pinging with a -n. In this case, I'm going to do a -n2. www.leodrager.com. And you can see, in this case, the number of times, realistically, check this out, one time it went through, and the other time it timed out at a 50% loss. So we can just run that again and see if there's an anomaly there. And it probably was, considering this time I ran it again. So interestingly enough, you can see that I dropped the packet right there. Other things we can do, ping, let's go back to help. Let's look at the TAC I. Yeah, and it depends. Sometimes you have a TAC I, sometimes you don't. It really just depends on what version of Windows you have. So we could do a ping, TAC I, and then the number 4, and then www.leodrager.com. And you can see that the I actually expired and transit. So I is specifically for the time to live. So I can set that. So in this case, the route is above 4 hops away between me and my destination, and I could slowly start tweaking this to see exactly when I get a response and when I don't, and that tells you kind of how far you are between you and your destinations in terms of the number of hops. So I'd want to dial this in. Normally I would do something like TAC I 1, see if I get a response, then 2, then 3, then 4, then 5, and then see when and exactly where they're timing out. And that could go all the way up realistically to 100 here. But you see, if I did it at I equals 10, I get a reply. But if I did it down at 6, I timed out. So we'll just, for giggles here, we'll do 8, that seems to be right in the middle, and we'll see if that gets a reply. And then that tells us on average, and 8 looks like it's timing out. So that's a little bit about the ICMP utility, or the ping utility. Ping is really the front end. Most of the time it's ICMP that goes across. So just in summary, we use the TAC I for time to live, the N for the number in which you actually want. We could have done a T. It's easy to show you a T real quick. TAC T, that'll just keep doing it until basically I tell it to stop, and you can see it's beyond the traditional 4, so that's enough there. You can also add in a -A for host name resolution. So what I encourage you to do here is realistically get to know the utilities instead of just looking at these utilities like ping. Okay, ping an IP address. Really get intimate with the utilities by looking at all of the options.